Okay, hello and welcome to the TMA webinar on this beautiful day, which happens to be the International Pathology Day. So it's great to see so many people. We have a lot of participants from all over the world. We have some people from the US, India, Japan, the UK, Switzerland, Singapore, and also some people from Hungary. So my name is Marcel Beretsky, Product Marketing Manager. I will be your host for today, and let me introduce Mr. Ákos Ágyi, PhD, who is an application specialist, a subject matter expert on TMAs, and who will guide you through this webinar. Just a few words about the logistics of the webinar. We plan it to last approximately 30 to 35 minutes, depending on the questions. Regarding questions, if you have any, please feel free to type them into the chat box, and at the end of the webinar, we will try and answer all of them. And also, this webinar is being recorded and it will be shared with all the participants after the event is finished. So, what is TMA? TMA, is it 3,4,5-trimethoxyamphetamine? We are getting very scientific here, and some of you might know that this is a hallucinogenic drug. No, this is not the case. This is not the TMA we are going to talk about. Or is it the terminal maneuvering area, which is a designated area of airspace around the major airport? You can see the beautiful map of the London TMA here, but no, this is not the case either. We are not talking about the TMA as the terminal maneuvering area, and we are not talking about the Russian Soyuz spacecraft mission, which is also called TMA. And this lovely box, this is a Yugoslavian anti-tank mine called TMA-2. No, we are not going to talk about this either. And last but not least, this is a tower-mounted amplifier, very technical, very lovely looking, but no, we are not talking about this. So to learn what TMA really is and why it's good for both research institutes and also pathology laboratories, let me hand over to my colleague, Mr. Ákos Ágyi, application specialist, and he will tell you in detail what TMA really is. Thank you.
Hello and welcome for everybody. And first of all, I would like to thank Marcel for this nice and interesting introduction. During today's webinar, I will show you what is a TMA. I will also show you how the TMA technique was developed. I plan to present you all the advantages of the TMA technique and the application fields of this technology. And towards the end of this presentation, I will show you how to make a TMA block, and briefly I will speak about our tissue microarrayers. Let's see first what is a TMA. Researchers and pathologists can combine hundreds of paraffin-embedded tissue specimens into a single paraffin block by using the TMA technology. Tissue cores are extracted from one or more representative region of a paraffin-embedded tissue block. We call this a donor block. Then these tissue samples are precisely arrayed into a new paraffin block. We call this a recipient block. On this slide, you can see representative images of a donor block after the coring process. Please notice the holes. We extracted the tissue core from these positions. And on the next image, you can see a full recipient block. Basically, this is your TMA block. Let's see how this technique was developed. The first TMA-like thing was developed by a researcher called Betty Fora. It was called a multi-tumor sausage. Basically, this researcher deparaffinized, dewaxed some tissue blocks. Then he cut the tissues on little stripes and assembled them and wrapped them with small intestine. This wrap, with this multitumor sausage, then was again embedded in paraffin and sectioned for analysis. Later, another researcher developed a similar technique. Basically, it was similar to the previous one. In this case, the researcher used plastic straw as casing instead of small intestine of small mammals. In 1990, Batifora improved his own method. He called it the checkerboard tissue block. Basically, the deparaffinized tissue was again cut in little stripes, and then he casted agarose over the tissues. Then these tissues molded in agarose were stacked on each other, and this stack of tissue and agarose was then embedded in paraffin. During the sectioning process, this is how looked like the sectioning surface or the cutting surface of this block. That's why it's called checkerboard tissue block, because it looks like, or it has the pattern of a checkerboard. In 1991, Miller improved this technique, and in my opinion, this was a trailblazer experiment because he didn't do the initial deparaffinization step. In this way, he saved some time. He just cut out the tissue samples from paraffin blocks directly and then assembled them into the already presented checkerboard-like structure. And the end result was similar to the previous one. In 1998, there was a big step in terms of this technique. Conan and his co-workers designed and basically marketed together with the Beecher Instruments company the first tissue microarrayer. This was a semi-automated device. Basically, it had two punchers, one for punching a hole in the recipient block and another one for punching the tissue. Later, other companies also produced different tissue microarrayers, and even Beecher produced a bigger, fully automated one. On the previous slides, I showed you that basically researchers tried everything, worked a lot to put together several tissue specimens on one block and ultimately on one slide. Let's see, why is this so important? Why they worked so hard to achieve this? The really good thing about TMA is that you can offer standardized conditions for all your samples during the staining process. Just imagine you have all your samples on one glass slide and you can stain them in one batch. If there is any difference between the staining intensity of your tissue samples, you can be sure that it is caused by biological reasons and is not caused by some error in the staining process. And in the meantime, you can save time, reagent, tissue, slides, workforce, and money. Let's see how looks like a TMA workflow. The first stage of a TMA workflow is a preparation step, when the pathologist or researcher select the donor blocks, the tissue blocks, which will be used in the study. In some cases, it is required to have a section on a slide from the donor block for a more precise tissue core selection. The tissue section on the glass slide can be studied on a microscopic level and can be annotated, for example, by using a pen, and then this annotated slide can be overlaid with the donor block image. If the customer or the user is using one of our digital slide scanners and our tissue microarrayers, the slide can be scanned and can be annotated by using our viewer software. It's much more easier than to use a microscope and a pen. And finally, our tissue microarrayer software is able to overlay it perfectly with the donor block image during the TMA building process. Anyway, after selecting the representative area or the region of interest, the tissue core will be extracted from the donor block and inserted in the recipient block. When the recipient block is finished, a laboratory technician can section it and can stain it. The really good thing about TMA is that the laboratory technician can apply any kind of stain on it, anything what is usable on normal tissue sections is usable on a TMA section as well. After the staining comes the interesting part, the scoring and image analysis. Of course, this can be done by using a microscope, but especially if you are using a lot of tissue cores, this will be madness. This will be really hard to do with a microscope. On the other hand, if you have a digital slide scanner, you can scan your TMA slide, and from this moment, you can visualize it on your screen by using viewer software. Basically, you can see all your TMA spots, you can zoom in and zoom out, and you can navigate easily. I think you can imagine that this mode of TMA analysis is much more easier than the traditional one. Moreover, if you already have your slide scanned, there are on the market image analysis software which is able to find automatically or with minimal user help the TMA spots, and these TMA spots will be clearly marked and annotated on the slide. For example, our case viewer software has this feature. And if you already have all your TMA spots annotated, then you can decide to run a quantification, an automated quantification software on all the TMA spots or on some selected TMA spots, just like I tried to show you here. Let's see now what are the main application fields of the tissue microarray technique. The tissue microarray is used in the biomedical research field. In cancer research, researchers tend to use it extensively for different purposes. For example, there are so-called prevalence TMAs to analyze the frequency of a molecular alteration in different tumor types. In this case, the tissue microarray contains sample from different types of tumor, and the researcher is trying one antibody or one probe to find a common marker on them. There are also progression TMAs to study the role of a marker in tumor initiation, progression, or metastatic growth. In this case, the TMA contains tissue samples from the same tumor type taken at different steps of the tumor's development. And there are also so-called prognosis TMAs, which contain tissues with patient follow-up data. The TMAs can be used for other non-cancer applications as well, such as Alzheimer's research or inflammatory disease research. The tissue microarray technique can be used in routine pathology as well. One of the use cases in routine pathology is the so-called on-slide control or internal control. In certain countries, the law requires the hospital to use control tissue on the glass slide near the patient's tissue. Now you can imagine that it's quite hard to float two or more positive and negative control tissue sections on a glass slide when you need to make enough space for the patient's tissue section as well. On the other hand, if you have a tissue microarrayer, you can create a miniature TMA with selected surely positive and surely negative tissue samples, and you can easily float it on the same glass slide, which also have the patient's tissue. Later, after the staining process, the pathologist, before evaluating the patient's tissue, can first check the control TMA in order to see if the staining quality is good enough for further diagnosis. Another use case in routine pathology is cost reduction. For example, in Copenhagen, one of our customers is using the TMA technique for breast cancer diagnosis. Basically, they collect multiple samples on one TMA block, and in this way they can save reagent, time, workforce, and ultimately money. Let's see now, how can we create a TMA block? Tissue microarrays traditionally can be created manually. Manual TMAs are created in a way that you are using a manual punching device. You punch out a tissue core from the donor block and then try to insert it into a special recipient block, which was casted in a special mold in order to already have some holes, for example. As you probably can see from these pictures, this mode of TMA building is labor intensive, is time consuming, and in the end you will get a low quality and low density tissue microarray. There are on the market so-called semi-automated tissue microarrayers. These machines move in a pre-programmed position over the donor and or recipient block. In this way, they help the user, but the actual punching and the insertion steps has to be done manually by the user. You can imagine that with the need for constant manual intervention, the semi-automated TMA creation is not quite fast. Fortunately, there are on the market fully automated tissue microarrayers. These instruments can make the punching and insertion processes automatically. Our company producing two fully automated tissue microarrayers. The small one is called TMA Master. It has 5 block capacity. We recommend it mainly for research purposes. The bigger one is called TMA Grandmaster. The TMA Grandmaster currently is the world's fastest and highest capacity tissue microarrayer with 72 block capacity. It's a real high throughput device. We recommend it for biobanks, pharmaceutical companies, or pathology departments with higher demands. In our fully automated systems, the drilling of the recipient block, the punching of the tissue from the donor block, and the sample insertion are computer-controlled and automated processes. And in the end, the user will get a high density and high quality TMA in record time. 3D Histech is a digital pathology company. Basically, we have everything what is needed for a tissue microarray laboratory. We have a basic manual kit for building tissue microarrays, and we have much more sophisticated, fully automated systems as well. If the user needs digital slide scanners to scan the TMA slide, we can supply a wide range of digital slide scanners. And we also have image analysis software for TMA spot finding and for various automated image analysis tasks. Let me show you a short video about our flagship tissue microarrayer, about the TMA Grandmaster. On this video, you will see how easy it is to use our system. Basically, the user just needs to select a donor block, and then the user can easily select by touching or by clicking the right part of the donor block for extraction. After hitting the start button, the system starts to work. The system automatically drills a hole in the recipient block. In the same time, the puncher unit is punching out a tissue core from the donor block, and when the tissue core is out, the system automatically transports it to the recipient block and inserts it there. During the work, you can open the block feeder door, and basically you can load more blocks in the device. I have to stress that this can be done while the device is working, is punching and inserting tissue cores on the other end of the device. Basically, this is why the TMA Grandmaster is the fastest tissue microarrayer on the market, because it's able to do certain tasks parallelly in the same time. After closing the block feeder door, the system automatically takes pictures from the inserted donor blocks, as you can see it on the screen of the device. And here is a shot about the camera. The TMA Grandmaster has a special feature, we call it PCR feature. Basically, if the user selects the PCR button, the system will insert the selected tissue cores in a clean PCR tube instead of a recipient block. These collected tissue samples can be used later for molecular analysis, such as PCR or gene sequencing. After finishing the TMA project, the recipient blocks can be easily removed from the device. And this is the end result. You can also remove easily the cassette which holds the PCR tubes. And inside in the PCR tube, you should see now the tissue samples. I would like to note that our smaller device, the TMA Master, can do basically the same tasks. The only difference is the capacity. The TMA Master has now the same tools and the same core feature set. Even the PCR feature is available for the smaller device as well. Finally, let's see who could benefit from purchasing a tissue microarrayer. On the top of the list are biobanks. Biobanks are institutions with huge collections of tissue samples. These institutions usually create and sell custom-made TMAs for the academic and for the pharmaceutical research as well. Usually, we recommend for biobanks our bigger system, the TMA Grandmaster. The tissue microarray technique can be useful for research laboratories as well for different reasons. For research purposes, we usually recommend our smaller system, the TMA Master. Pharmaceutical companies could be also interested in using the TMA technology to identify therapeutic targets or new potential targets for their drugs. For pharmaceutical companies, usually we recommend our bigger, higher throughput system because usually they are working with high number of tissue samples. As I already mentioned, pathology departments and hospitals can also use the TMA technique in order to ease their work. It can be used in diagnosis, for cost reduction, or for creating control TMAs for internal control purposes. For pathology departments and hospitals, we recommend both of our tissue microarrayers depending on the size of the actual pathology department and depending on their workload. And finally, antibody and probe manufacturers can also benefit from using the TMA technology in order to test their probes and or their antibodies. If you are from a different institution, please leave us a comment in the checkbox and tell us what is your business. Let us know how can we improve your work or your existing TMA workflow with our systems. If you are interested in our tissue microarrayers, please visit our website at 3dstack.com/TMA. On this site, you will find all the technical details about the instruments. Finally, I would like to thank you for your attention. If you have any question, as Marcel said, please type it in the chat box. We will come. We are waiting for the questions, and we will answer them shortly. Thank you very much.
Thank you, Ákos, very much for this interesting presentation. I'm sure that now everybody understands what TMAs are. So let me also encourage you to type your questions into the chat box so that we can answer them. Thanks.